In 1869, a Russian chemistry professor named Dmitry Mendeleev was writing a textbook for his students when he began to wonder how he could best explain to them the 63 elements that were known at the time. To help formulate his thoughts, he constructed a card for each element. On each card he wrote the name of the element, its atomic weight, its typical properties, and its similarities to other elements. He then laid the cards out like a game of solitaire and began arranging them over and over, searching for patterns. Then came the moment of discovery. Before him was something extraordinary. The elements fell into 7 vertical groupings. Each periodic grouping had members that resembled one another, both chemically and physically. Mendeleev had discovered the periodic table of the elements, a map showing how all the elements related to one another. A map so precise that Mendeleev believed he could also use it to predict the existence and properties of 3 elements no one had yet discovered. One would be like boron, he said, one like aluminum, and one like silicon. Eventually, the elements were discovered, and Mendeleev was proven right.
There was actually a little bit of controversy because a German chemist named Lothar Meyer had come up with roughly the same idea. But Meyer didn't quite have as much courage. So that's actually an interesting thing. Here is this German who comes up with the same idea of periodicity, of which there were hints already before, but he doesn't make the predictions that Mendeleev does. So here we see the power of a risky prediction in having people accept a theory. There is nothing more powerful than making a prediction that's not obvious.
And then have it come true.
And have it come true. Mm. The periodic table is our icon. I mean, it's what we associate with chemistry. You go into any chemistry room, you see it.
Why is the periodic table of elements significant? It forever changed the way that everyone would learn and understand the elements. The periodic table of elements is to chemistry as notes of music are to a Beethoven sonata. In honor of Mendeleev, his name is now literally attached to the periodic table. The element 101 was named after him. It's called Mendelevium.
Another important development was the idea of atomic number.
When atomic number was discovered, it was realized that it was not atomic weight that was the correct ordering principle, but this other quantity called atomic number. It later turned out to be associated with the number of protons in the nucleus. It was the work of Moseley, who was picking up on a suggestion made by an amateur scientist, a Dutchman called Van den Broek. Van den Broek doesn't get much credit. One, because he was an amateur. And Moseley acknowledged the role of Van den Broek when he began his papers by saying that he was doing this work in order to verify the Van den Broek hypothesis, that there is a number that characterizes every element. And he very quickly found that that is indeed the case. He used X-rays to do this. Had it not been for the discovery of X-rays, that work would have been delayed.
He found that arranging the elements according to atomic mass made the most sense because the properties of the elements repeated at regular intervals, or periods, thus the name periodic table. He left some blank spaces in his table to make the properties and masses line up. He even predicted the properties of those missing elements, and he was correct. When scandium, gallium, and germanium were discovered, they had properties very similar to the properties predicted by Mendeleev. But, as often occurs in scientific discovery, his amazing work raised a tantalizing question. Why was it that a few elements did not seem to fall into the right place if arranged by atomic mass?
And the scientists were off again, researching and investigating,
looking for the answer to this question. About 40 years later, an English scientist named Henry Moseley discovered that all of the atoms of an element had the same number of protons, and this led to the modern definition of atomic number. Remember that an element's atomic number tells the number of protons in the nucleus of the atom. Moseley also discovered that it made more sense to arrange the elements by atomic number than by atomic mass. When the elements are arranged by increasing atomic number, the properties of the elements repeat, just like they did on Mendeleev's table. But there is no need to fudge. Remember, when Mendeleev arranged the elements in order of increasing atomic mass, in a couple places he flip-flopped and placed the heavier element before the lighter element, so that the elements would be in the correct group according to their properties. However, when the elements are instead arranged in order of increasing atomic number, no fudging is necessary.
The periodic table today reflects the work of both Mendeleev and Moseley. The result of their work is known as the modern periodic law. The modern periodic law states that the chemical and physical properties of the elements are periodic functions of their atomic numbers. Periodic function just means that something repeats according to a pattern. So another way to state the modern periodic law is to say that the properties of the elements repeat in a pattern when the elements are arranged by increasing atomic